Hi again, everyone. Okay, so now what we're going to do is we're going to graph these linear inequalities. Okay, so just to review, we need to put these in slope-intercept form. So we're going to solve these here in slope-intercept form and make sure that they are equal to y or greater than or equal to y in this case. Okay, so first I'm going to solve this guy over on the left. I'm going to solve the red inequality. So to solve, we're going to actually subtract. Oops, wrong color. We're going to subtract 5x from both sides. Okay, we go through solve both of these. Okay, excuse the handwriting. I'm doing this all with a mouse. Okay, and then once that happens, I'm left with 8y, which is greater than or equal to negative 5x plus 56. Now, I like to put my slope first. You really don't have to, as long as you know that it is the coefficient in front of that x value when you have this solved for 1y. Okay, but I like putting my slope first in that form, y equals mx plus b. Then I'm going to divide everything by 8. So just to review, everything by 8. Okay. And this ends up being, because that's a positive 8, I don't flip my inequality sign. So this stays the same. Y is greater than or equal to negative 5/8 x plus 7. Okay. So there's my first inequality. All right. My second inequality is actually much simpler. It's just a one-step solving. I just have to solve for 1y here. So all I have to do on both sides is just subtract that x. Okay. So it's already 1y as is. I just have to move the x to the other side. Therefore, y is less than or equal to negative x plus 10. Okay. So slope and y-intercept are in good shape. I'm going to graph my red line first. Okay. So here I have my y-intercept is this 7, which is that 0, 7. And we're going to actually graph this. We know these inequalities could go into all 4 quadrants here, but given real world problems, typically what we're looking at is we're looking at inequalities that are typically in the first quadrant. Okay. Now we know, again, we know this could extend past, but our answers here, we're typically going to look at all of the positive solutions, which is only quadrant 1. Okay, so these are all by ones here. That's my scale. So I'm going to start here at 0, 0 and go up 7 spaces to that y-intercept. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to plot my point there. And then because my slope is negative 5/8, I'm going to move down 5 to the right 8. I'm going to come down 5 here. 1, 2, 3, 4, 5, and then right 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's the next point. Let's see if I can go down any further. 1, 2, 3, 4. I can't go down any further. It would be something if I was following my scale somewhere all the way down about here-ish. Okay, if I'm following my line. Okay, so that's my first one. The line that I would draw here is going to be a solid line, and it's a solid line because of this greater than or equal to. Okay, the equal to piece tells me it's a solid line. It's not a dotted line in that case. So I'm just graphing to the best of that ability. Let's see if I can adjust that ever so slightly. I'll do a different one. Here we go. Okay, so there's my line, and I could extend that if I need to. Okay, we know that lines extend infinitely forever. So if I'm just going to extend this just a little bit more, come on. Oh well. So there's my first line. Okay. Now, the shading for this guy, we know where the shading is going to go. The greater than would mean we're shading on top of the line. So we know our shading is going to be all the way, all of this stuff up here. So I'm just going to briefly shade that in, and then we'll find where that intersection is in the end. Okay. My second line, y is less than or equal to negative x plus 10. I go to my y-intercept, which is 10, 0, 10. So I had 7, 8, 9, 10. It's all the way up here. And then I'm using this slope to come down 1 to the right 1 because it's a negative slope. Okay. So I'm just quickly going to erase those annotations there. Excuse me. Nonetheless. All right, so let's just take this and let's keep going down 1 to the right 1. So we went down 1 to the right 1. That will be this next point. I could keep going. The nice thing is with the slope, I can use an equivalent slope. So let's say I want to go down 5 to the right 5. I'm actually going to do that because that still is negative 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It gives me a little bit more distance here, okay? Down 5 to the right 5 again. In fact, let's go down 6 to the right 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you see those points as they intersect, they're actually coming down at a slightly quicker rate, okay? So here's my next line. I'm going to graph that line in blue. Let's see if I can draw that perfectly. There we go. All right. Now, where's the shading here? The shading then would be below my blue line. So here's what's interesting. You see all this blue stuff that is above that blue line, okay? And my shading for this blue line is going to go below it. Okay, so I'm going to take my marker here. I'm going to shade below it. I'll shade it in brown just for a different color's sake. Okay, so here's all my shading for the blue line. Now, again, just as a reminder for all of you, we want the intersection of this shading. Okay, so where do both of these intersect? They intersect in this little section right here. Okay, so I'm going to erase all of the other shading that is not within that same realm. Okay, so here's my eraser. This shading, although it is above that blue line, that red line, which is what we wanted, that's not below the blue line. So we don't want any of that shading. This shading, although it is below that blue line, is also below the red line. We don't want that one either. Okay, so we want that intersection. So all in all, in the end, our shading, I'll color this in red, all of our shading is going to be in this little section. So this is where all of your solutions will lie. You have actually a plethora of points in here, actually infinite points in there. And yes, technically there are points all the way over here, but you would not have any negative values for your X value up here, okay? The last piece is when you're answering, you can choose any point that is in the shading. And because these are solid lines, you can actually choose a point on the line too, okay? Because these are equal to, any of these points on the lines would also be a solution. So that works as well. So make sure when you are actually answering these questions and choosing a coordinate, you're choosing a coordinate that's either in the shading, which is probably the easier of the two, or depending on if you have a solid line, it could also be on that solid line as long as it answers that question if it's between that shading as well. Okay, so a simple answer here would be this coordinate that's right in here. Okay, this coordinate, if you look at it, this is 1, 1, 2, 3, 4, 5, 6, 7, 8. 1, 8 would be a solution to this system, okay, because it is in that shading, okay? So you have a 1, 8. You could also go to 2, 7 right here, which would work as well. 3, 6 is in the shading. 4, 5 is in the shading as well. So you could go depending on what your question is. If you're allowed to have decimals, you could have decimals or fractions. That works as well. Okay, but you have a bunch of answers that are all within. Okay, hope that helps, and let us know if you have any questions in the end.